Hi, this is Geometry Lesson 2-3, Parallel Lines and Triangle Angle Sums. In this lesson, we'll be able to solve problems using the measures of interior and exterior angles of triangles. Let's start with explore and reason. Two parallel lines never intersect, but can two lines that intersect ever be parallel to the same line? So you know two parallel lines never intersect, right? They never meet. But could there be two lines that intersect ever parallel to another same line? Let's draw point P. We're going to draw lines A and B that intersect at point P as shown. So obviously, those two lines intersect at one point, which means they're not parallel by definition. Could there be another third line that is parallel to both of them? First, part A, place a pencil below the intersecting lines on your paper to represent line C. So if you have a paper, please take them out. I have a paper here. So you're going to place the pencil below the intersecting lines on your paper to represent line C. So first, put your paper on top of your textbook and draw the two lines with a point P. Your lines could go further away. But really, it could be any two intersecting lines. And you're going to draw line C as well. You're going to rotate the pencil so it's parallel to line B. Right? And so that it is parallel to line A at the same time as line B. So try to use your straight edge and see if you can find a line that's parallel to B. Okay? So if you use your straight edge, you can make a straight line to represent C and make a parallel line that represents a parallel line to B. But would there be any parallel line that's parallel to B also parallel to A? Well, not unless you change the angle of this line, right? If you change the angle of this line to be parallel to A, then now it's not parallel to B anymore, right? It's only parallel to A. So would there be any line that is parallel to both of them, not just either of them? No, there will not be a line that could be parallel to both intersecting lines. So the answer is no. So no. And you can say, no, the pencil cannot be parallel to both lines at the same time. So instead of pencil, we use the ruler, right? But you can also use a pencil or anything that's straight. Part B, can you adjust your drawing of the two intersecting lines so you can rotate the pencil to be parallel to both lines? As we looked at it just now, no. No matter how small the angle between the two lines, the pencil cannot actually be parallel to both. Yeah. So what did we learn from this exploring reason? There is no one parallel line that's also parallel to another line that is intersecting it. So topic essential question. What is true about the interior and exterior angle measures of a triangle? Now we're going to look at triangle and some parallel lines and how they're related. Look at example 1. Investigate the measures of triangle angles. So Forget about the triangle angle sum, okay? You don't know the triangle angle sum theorem. That's what we're going to look at today. So what appears to be the relationship between the angle measures of a triangle? So using a pencil and paper or scissors and paper, construct several triangles of different types. So take a moment to draw different types of triangles with different angles. You can draw a scalene triangle, obtuse triangle, right triangle, acute triangle, or you can also draw a regular triangle. Do you know all those types of triangle? Try to draw as many variety of triangle as possible. You could draw equilateral triangle. Okay. You could draw your own triangle, but it has to have 3 sides. Okay, so I drew 3 types of triangles here, right? And you can label their angles with numbers. So let's go ahead and label your angles inside your triangles, just like the diagrams here. Okay, so I labeled my interior angles of the triangles like this. So give them unique numbers. You're going to trace the angles from each triangle and place the vertices together with the sides of the angles sharing a vertex and a ray. So you'd have to cut out the angles, actually, the triangles, and then cut out your triangles. Okay? What if you divide your triangles, okay, like this, and then like this? So if you cut your triangle like this and try to put your angles together in a straight line, on a straight line. So if you look at example 1, this triangle, if you cut this triangle and put all those angles together on a straight line, they make a straight line. And this triangle as well, that triangle as well. So all the angles actually, if they're placed right next to each other, they will eventually make a straight line, 180 degrees. So for each triangle shown, the angles combine to form a straight angle. So the sum of the angle measures of a triangle appears to be 180. So we have figured out the pattern. I know you already know that the sum of triangle would add up to 180, but this is a good way to explain why. Try it yourself. So let's look at try number 1. Given 2 angle measures in a triangle, can you find the measure of the third angle? Explain. How could you figure out the measure of the third angle if you have 2 angles given already? First of all, can you find the measure of the third angle? Yes or no? Yes. How? Because if you know the measure of all 3 angles will add up to 180, you can subtract the 2 given angles and figure out the third angle, right? So yes, if the sum of the measures of all of the angles in the triangle is 180 degrees, subtracting the 2 known angles from 180 degrees gives the measure of the third angle. Okay, so that would be how you figure out the third angle if it's not given with the other 2. Let's look at theorem 2-10 on the next page. There are a point not on a line. There is one and only one line parallel to a given line. Does that make sense? If you look at this line B, and there's a point that is not on line B, there's only one line exactly parallel to line B. So there's only one line that goes through that specific point that is not on the line that is parallel to the line. Okay, so if you have line B, then line A is the only line parallel to B through point P. Okay, theorem 2-11 says triangle angle sum theorem. The sum of the measures of all the angles of a triangle is 180 degrees. So if you add up all the interior angles of the triangle, you will get 180 degrees. If you didn't know that, there you go. Alright, so now let's prove that. Example 2. We're going to prove the triangle angle sum theorem. Okay? Other than just cutting out the triangles, we want to prove it by logic. How do we prove it? Given that triangle ABC is given, we're going to prove that angles 1, 2, and 3 add up to 180 degrees. So what is our plan? We're going to draw a line through C because straight angle measures 180 degrees. Okay? We're going to draw a line like that. And this line should be parallel to the line containing AB. So using the theorem 2-10, we know that the point C, which is not on line AB, there is only one parallel line that goes through point C that is parallel to AB. So if we draw a line that's parallel to C, we can use all the properties relating to parallel lines, right? So that's our plan. We're going to draw a line. And then this straight angle will measure 180 degrees total. This line should be parallel to the line containing AB. So alternate interior angle relationship is formed, and we could use that. So in this diagram, we see a parallel line that goes through point C, and that's parallel to AB. You can use theorem 2-10 to justify this, and by alternate interior angle theorem, you know that angles A and 4 are congruent to each other because they're alternate interior angles of this transversal that goes through the two parallel lines. And so they're equal to each other, right? And also, angles 2 and 5 are congruent to each other, so their measures are equal to each other. So I'm going to draw two angle lines to show they're congruent because of alternate interior angles theorem. So you can also say by an angle addition postulate, measure of angle 4 plus measure of angle 3 plus measure of angle 5 would add up to 180 degrees because this is a straight line. Does that make sense? And then using the congruent statements, you can say, oh, I can substitute this. And so by substitution, I'll have 1 plus 3 plus 2 will add up to 180 degrees. And that's what we exactly need to prove, right? So therefore, using the commutative property of addition, measures of angles 1, 2, and 3 are equal to 180 degrees. And now we have proven the triangle angle sum theorem. All the angles inside the triangle add up to 180 degrees. Let's look at try number 2. How does theorem 2-10 justify the construction of the line through C that is parallel to AB? So how did we justify this? How do we use this to justify? How do we make sure that the step is correct? What do we do? Well, what does the theorem say? The theorem says that through a point that's not on the line, there's one and only one line parallel to the given line. Because of that, we can say that there is one specific line, parallel line, that goes through point C that is parallel to line AB. Okay? So basically, you can state out the definition of the parallel of the theorem. Okay, so you can basically say that this proof uses the fact that there is only one line through point C that is parallel to line AB. Let's look at example 3 on the next page. You're going to use a triangle angle sum theorem. How do we use it? How is going to help us solve problems? What are the values of x and y? What if we have angles that are unknown and we want to figure that out? You're going to write and solve equation that relates the measures of the angles of the triangle TRS. So we have these two angle measures given, 78 and 32. Using that information, you can figure out the third angle, x. So 32 plus 78 plus x is going to be 180. So if you subtract 32 and 78 from 180, you get 70, and that is the measure of x. So using the triangle angle sum theorem, x is 70. To find the value of y, notice that angle QRS is a straight angle. So you know the relationship between y and 78, right? They're going to make a linear pair. So 180 minus 78 would give you the angle of y, which is just 102. So the value of x is 70 and the value of y is 102. So use the triangle angle sum theorem, use the linear pairs theorem to figure out the missing angles. So use whatever you've learned so far to figure out the missing angles. Try number 3. What are the values of x and y in each figure? Figure out these missing values for parts A and B. Pause the video and see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Part A. Using the triangle angle sum theorem, you can figure out the angle for x, right? 180 is equal to 96 plus 35 plus x. So x is 180 minus 96 minus 35 degrees. So x must be 49 degrees. Check your answers. What about y? Well, we know that the bigger triangle would also have a triangle angle sum theorem, right? So 77, the value of x, plus 35 plus y should be 180 degrees. So 77 plus 49 plus y plus 35 is 180 degrees. It might seem like we're adding 4 angles, which we are, but y plus 35 is just one angle for this vertex, right? So remember that. And your y could be figured out by subtracting all of that from 180 degrees. So y is 180 minus 77 minus 49 minus 35, which will simply be 19. Okay, so y is 19, x is 49 degrees. Check your answers. You got it right? Good job. Part B, in the same way, you're going to use triangle angle sum theorem to figure out x, and that's a vertical angle, so you're going to have the same value with the measure of x, right? So using that, first you figure out x, using that measure, you can figure out the measure of y. So x will be 54 degrees, y is 74 degrees. Okay? Did you get it right? If you got all of them right, good job. Let's look at theorem 2-12, triangle exterior angle theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. We got some vocabulary here. What is the exterior angle and what is the remote interior angles? So if you look at this diagram, all your interior angles are the 3 angles inside your triangle. Exterior angle is when you extend one segment of that one side of your triangle and make a straight line, you will get an exterior angle that is a linear pair for one of your interior angles. Does that make sense? So if you extend this side and make a straight line over here, angle 1 is the exterior angle. It's an exterior angle. You will have another exterior angle here, right? You will have another exterior angle here. But which side are we doing it? Make sure your exterior angle is a linear pair with your interior angle. So if you draw a line over here, your exterior angle is this part. That is a linear pair with your interior angle. So exterior angle will be the sum of two other remote interior angles. So the interior angle that is a linear pair to your exterior angle does not appear in this theorem, okay? The other two angles that is not the linear pair of your exterior angle are called the remote interior angle. So 2 and 3 in this diagram will be remote interior angle to the exterior angle 1. So in this case, your measure of angle 1 is equal to the angles 2 and 3. Okay? We're going to apply this triangle angle exterior angle theorem and figure out some missing angles. What is the missing angle measure in each figure? Part A. We don't know the third angle here. So you can either figure out the third angle here and subtract that from 108 to figure out the exterior angle. But if you know theorem 2-12, you can save some steps. You already know that 45 plus 75 will equal to the measure of angle 1. So that's a lot easier than trying to figure out the third angle and then subtract that again from 180 degrees and figure out angle 1. Just add these two angles. So 45 plus 75 is 120. That is your exterior angle 1. Okay? Part B, in the same way, your exterior angle 109 is equal to 51 plus your angle 2. You don't know the measure of angle 2. But you can figure out by subtracting 51 from 109, right? Because by exterior angle theorem, you know 109 is equal to 51 plus measure of angle 2. So your measure of angle 2 is 58. So depending on which angle is missing, you can use the exterior angle theorem to figure out the missing angle. So on your next page, there's try number 4. What is the value of x in each figure? Use the triangle exterior angles theorem and see if you can figure it out by yourself. Come back when you're ready for answer. Okay, are you ready? What is x? You just add 54 plus 57. They're the two remote interior angles. And the triangle exterior angle sum theorem says that if you add these two remote interior angles, you get the measure of the exterior angle x. So 54 plus 57 is equal to 111 degrees. So your answer is 111 degrees for x. What about part B? What is the value of x here? Now x is one of those two remote interior angles, right? So 104 is equal to x plus 49. You just subtract 49 from 104 and you will get x is equal to 55 degrees. Okay, check your answers. See if you got it right. All right, moving on to example 5. Apply the triangle theorems. Application. Cheyenne built this display for her ornament collection. Ooh, it looks very intricate. Each shelf is parallel to the base. So if you look at each shelf, the base of each shelf is parallel to the big base on the ground. She recalls only the angle measures shown in the diagram here. Now she wants to build another just like it. What are the measures of angles 1, 2, and 3? We just want to figure out angles 1, 2, and 3. So using the angles that we see here, can we apply the triangle theorems in order to figure out the missing angles here? First, we're going to begin by writing equations for the unknown angle measures. So what are the relationships we see? Since the bottom and top shelves are parallel, you can apply the corresponding angles theorem, right? So since these are parallel lines, the transversals here will make corresponding angles. So 55 plus 1 is one angle, and that corresponds to the angle here, 75 degrees given. So 55 plus 1 is equal to 75. Using the triangle exterior angle theorem, we can say that angle 1 plus angle 2 is equal to 75. If you look at this little triangle here, there are lots of triangles in this diagram. You can see which triangle you want to use according to the theorems that might work, right? So if you look at this triangle inside in the middle, right? Then you can identify 1 and 2 as remote interior angles to the exterior angle 75 here, right? So you can say 1 plus 2 is equal to 75. And using these equations, oh, we have one more. Using triangle angle sum theorem, we can say that 45 plus 45 here, plus measure of angle 1 plus 3 plus 55 is equal to 180 degrees. Now we're looking at this bigger triangle. Let me use another color. So now we're looking at this triangle. Triangle angle sum theorem says 45 plus this 45 plus this, all of these angles added together will equal to 180 degrees. Okay, so we're going to solve for angles 1, 2, and 3 using these equations. So the first equation, you can just subtract 55 from 75 and get 20. Your angle 1 is 20. Second equation, because you know angle 1 now, you can substitute 20 into your second equation. Say 20 plus measure of angle 2 is equal to 75. 75 minus 20 is 55. So measure of angle 2 is 55. And then use the third one. You already know measure of angle 1. So 45 plus 45 plus 20 plus measure of angle 3 plus 55 is 180. So subtract all of these from 180 to get measure of angle 3, that's equal to 15. Now we have figured out all the missing angles that they want us to figure out. So the measures of the angles are 20, 55, and 15. Good. Now it's your turn. Try number 5. What are the measures of 4 and 5? There was a reason that we didn't solve for 4 and 5. So figure out the measures for 4 here and 5. Come back when you're ready for answers. Are you ready? So from example 5, we already figured out measures of angles 1, 2, and 3. So 1 is 20, 2 is 55, that's 55, and 3 was 15. And so using all those information, can we figure out 4 and 5? Yeah. So looking at this triangle on the outside, you can use a triangle angle sum theorem and say 45 plus 15 plus measure of angle 4 is equal to 180 degrees. Okay, and you can say, yeah, I'm going to subtract 180 minus 45 minus 15 to get 120 degrees. And so your measure of angle 4 is 120 degrees. What about 5? Using the same theorem, we're going to look at this triangle on the bottom and use the triangle angle sum theorem and say 180 minus 45 minus 55 will be measure of angle 5. And that is equal to 80 degrees. So now you figured out 4 and 5. Check your answers. 4 is 120 degrees and 5 is 80 degrees. How would you explain it? How did you get it again? Which theorem? Using the triangle angle sum theorem, we could subtract the other two given angles from 180 degrees to get their measures of angles. Okay, now you know how to figure out missing angles using the triangle theorems. Let's summarize our lesson. Angle measures of triangles. We looked at interior angle measures and exterior angle measure. So the sum of measures of all the angles of a triangle is 180 degrees. That's the triangle angle sum theorem. Exterior angle theorem, triangle exterior angle theorem is going to be when you have an exterior angle of a triangle. Your exterior angle is equal to the sum of the two remote interior angles. Okay, that summarizes our lesson 2-3, parallel lines and triangle angle sums. If you have any more questions, please ask Ms. Kang in class. Otherwise, we'll continue with the next lesson 2-4, slopes of parallel and perpendicular lines in the next video. Thanks. Bye.